Have you ever wondered how a huge coffee chain with shops in hundreds of different cities makes sure its cash registers can talk to a central server? Or, how a company's headquarters in one state can securely grab data from an office clear across the country? It's definitely not as simple as just plugging into the internet. There's this hidden, complex world that keeps our entire modern economy running. So let's pull back the curtain and take a look at the corporate network.
This is the absolute core puzzle for any business that's growing. You've got all these different locations, right? Each one has its own little local network, a LAN. But how do you tie them all together into one big, secure system? Well, this bigger network, the one that connects all your separate sites, that's what we call a wide area network, or a WAN.
To make this all feel a bit more real, let's use an example. We'll call it Network Chuck Coffee Co. So they have a headquarters and their main data center, and they're both in Dallas. But their coffee shops? They're everywhere. Phoenix, Seattle, you name it. Now, why do they need to be connected? Well, think about it. The phone system, all the sales data, payroll, everything important lives in that central data center, so those shops need a constant, super reliable link back home just to function. The big question is, how do we build that?
Okay, let's start by hopping in a time machine and going back to the original blueprint for corporate networking. Before the internet was, the internet we know today, the solution was direct, it was physical, and it was kind of brute force. The whole idea was incredibly simple. If you need a secure, private road for your data, why not just build one?
And this private road was called a leased line. Just like you'd lease an apartment, a company would literally lease a physical cable connection from a telecom company that ran directly from one office to another. So for our coffee company, that means one physical leased line from Phoenix to Dallas and a completely separate one from Seattle to Dallas.
Now let's talk about speed for a second, because this is where the perspective gets pretty wild. These old leased lines, a lot of them are called T1 lines, were considered the Ferraris of their day. But their top speed? Just 1.5 megabits per second. To put that in context, your home internet connection right now is probably hundreds of times faster. A T1 line would have a hard time even streaming a low-quality YouTube video today.
The one big advantage was guaranteed performance. I mean, it was your own private line, so nobody else's data could slow you down. But the downsides were massive. First, they were incredibly expensive. And as you added more and more coffee shops, you'd end up creating this ridiculously complicated, costly spiderweb of point-to-point connections. It just didn't scale well at all.
Yeah, that messy web of leased lines just wasn't going to work long-term. The industry needed a much smarter way to connect all of a company's sites without having to run a dedicated cable for every single link. And this led to the next major evolution, basically moving all that complexity into the carrier's own private cloud.
And that solution was MPLS. With MPLS, our coffee company just needs one connection from each of its sites, Phoenix, Seattle, and Dallas, that plugs into the provider's network. And then the provider handles all the complicated connections between the sites inside their own cloud. It's kind of like having your own private highway system, but it's built and managed by somebody else. So the magic behind MPLS is right there in the name. Label switching. When data from a coffee shop hits the carrier's network, it gets a special label, almost like a VIP pass. The carrier's gear only has to look at that simple label to guide the data along a preset private path. This makes sure your data stays totally separate from every other customer, even though you're on a shared network. It's security and privacy baked right in.
And really, that's why MPLS became the standard for so long. It solved the biggest headaches of leased lines. It made connecting a ton of sites way simpler, it was secure by its very nature, and it gave you really stable performance. But it also introduced a killer feature, quality of service, or QoS. This let businesses tell the network which traffic was most important. For our coffee company, it meant their phone calls could be treated like VIPs, getting a crystal clear line even if the network was slammed.
So MPLS was perfect for connecting dozens of coffee shops that were all over the country. But what about that massive fire hose of data that needs to flow between two super important buildings in the same city, like our headquarters and data center back in Dallas? For that very specific job, you need a totally different kind of connection.
And that's called Metro Ethernet. The best way to think of it is just as a super long, super fast Ethernet cable that's running under the city, directly connecting two buildings. We're talking about speeds of 1 or even 10 gigabits per second now. It's the perfect solution when you need that massive data pipe between a corporate office and a data center that are in the same general area. Let's just quickly compare the two. MPLS works at what we call Layer 3, which means it's smart about routing your data across a complex network. It's like a GPS for your packets. Metro Ethernet, on the other hand, is a much simpler Layer 2 service. It just focuses on blasting data from point A to point B, almost like a physical cable. One's a whole highway system, the other is more like a single private superhighway.
Now, both MPLS and Metro Ethernet are fantastic technologies, but they both share one major thing in common. They can be very, very expensive. And this created a whole new challenge. Could businesses maybe use something much, much cheaper to connect their sites? Something like the public internet?
And right here, we get to the fundamental conflict of modern networking. On one side, you have these private networks like MPLS. They're reliable, they're secure, but they cost a lot of money. On the other side, you've got the public internet, which is incredibly cheap and it's available everywhere. But it's inherently unreliable and totally insecure.
There's a great quote that just perfectly captures this reality. When your data is out on the internet, it's not being gently carried from router to router. It's being thrown. It's just out there in the wild, competing with everybody's Netflix streams and video games, and without any protection, anyone could potentially just take a look at it.
So how do you make the internet safe for your business? Well, you use a VPN, a virtual private network. A site-to-site VPN creates a secure, encrypted tunnel that goes right through the public internet. So all the data from our Seattle coffee shop gets encrypted before it even leaves, it travels through all that internet chaos, and then it's only decrypted when it safely arrives at the Dallas data center. This solves the security problem. But, and this is a big but, it doesn't solve the performance problem. Because you're still using that big, bad, wild internet, connections can be slow and unreliable. Those important phone calls can sound awful because there's no way to prioritize them over anything else. And the VPN tunnels themselves, they can just drop for no reason at all. Sure, it's cheap, but you definitely get what you pay for. And this is where the very latest evolution in networking comes into the picture. SD-WAN. It's the technology that's specifically designed to give you the best of both worlds. It takes those cheap, standard internet connections and uses really smart software to make them behave like one of those expensive private lines.
And that's really the core reason SD-WAN is taking over the world right now. It solves the performance and reliability issues of using the internet, sure, but more importantly, it's built for the modern cloud era. As businesses use services like AWS and Azure more and more, SD-WAN can intelligently send traffic directly to the cloud, instead of inefficiently routing it all the way back to a central data center first. It's just a much smarter, more direct approach. Which brings us to our final thought. The corporate network, it used to be all about connecting branch offices back to a central headquarters. But now, the destination for our data is off in the cloud. So as our applications and data keep moving out there, how is the very idea of a corporate network going to have to evolve next?